Here we have a constant coefficient second order linear ODE, and we have boundary conditions. Note that there is a condition on the value of y at 0 and a condition on y at 1. So we can think of 0, 1. This is like our domain is like this little rod where this ODE applies. So our solution is going to be constrained to have value 1 here and value 3 up here. And then the ODE is going to do something in here. And what that actually sort of looks like is kind of this. It's probably a bit bumpier than that, but anyway, that will do. Let's go through our normal solving process. We guess y equals e to the lambda t. We obtain our characteristic equation. Lambda squared plus 2 lambda plus 1 equals 0. We solve the characteristic equation. We find that there are 2 repeated eigenvalues. So we know our general solution in this case is y a e to the minus t plus b t e to the minus t. Okay. Let me just check that I'm correct. Yep, looking good. Now we've got to apply our boundary conditions. I should actually say that this is a boundary value problem, or a BVP. We've got to apply our boundary conditions to make sure, or to find A and B. So our first boundary condition, we simply substituted in y equals 1 if t equals 0. That gives us 1 equals e to the 0 is 1 plus b t times 0, well, that's just 0. So immediately we find that a is equal to 1. So that's good news. We've solved our problem. We've gotten a bit of an advancement. So we now have that y equals e to the minus t plus b t e to the minus t. And we have that y, when t is 1, y is 3. So we can substitute that in as well. E to the minus t, e to the minus 1, sorry, plus b, t is 1, times e to the minus 1. And you'll note that there's this factor of e to the minus 1. So 3e equals 1 plus b. So b equals 3e minus 1. Right. A lot of students find this so tempting to evaluate and round to 2 decimal places. That's naughty. Keep it in exact form. You want an exact solution. You don't want a solution that's got some weird rounding error in it. So we now have, let me just firstly check that I'm correct. Yes, I'm correct. Excellent. We now have our particular solution. A was equal to 1. Got e to the minus t plus b, which is 3e minus 1, t e to the minus t. Okay, that is our particular solution in this case.